Thank you, Patrick. Good afternoon. I will be talking mainly about the glass industry sector. And the flow of my presentation will be, I will be starting with the energy consumption in the Indian industries, then specifically coming on to the glass sector, a bit about the manufacturing process and the work that TERI had done in the Firozabad cluster. So if we see the commercial energy consumption pattern in India, then we can see very clearly that industry is one of the largest consumer of commercial energy, followed by transport and building. And if you see the type of fuel being used in industry, it is the fossil fuel. So the importance for our country is to reduce the energy, and that too the fossil fuel. So industry plays a major role in that. And if you see the future projection of the energy consumption in India, then we can clearly see that in future also, industry will be going to play a major role. Till 2050, industry will be among the largest consumers. And again, the fuel use will be the fossil fuel, the coal. So again, it highlights for our country that we need to conserve our energy, the fossil fuel. If we talk about the present industry sector in India, then it is typically classified in two categories. One is the large industries, whereas in the morning session, the Secretary BE has mentioned that we have few very good plants in cement and fertilizers. And apart from these two sectors, if we talk about any new capacity addition among the large industries, it is always the state-of-the-art technologies. And for the old plants or the existing plants, the government of India had come out with a very innovative policy of PAT scheme. It has been talked about that specific energy reduction targets have been given to industries to reduce their energy consumption for the large industries. But when we talk about the small industries, the MSME sector, although they are large in number, they are located in clusters, but the main fact about them is that they use obsolete technologies, and the manpower available with them is not so skilled. And when we talk about specifically about the glass sector in the country, in India, it covers under both the categories. It's one of the sector in India that is under the glass sector also, and that is under the MSME sector also. So it's very unique sector in the country. Just to give you a snapshot of Indian glass industry, the total production capacity in India for glass is around 12,000 tons per day. And we have very large players like HNG, Hindustan National Glass, the multinational like Saint-Gobain, Asahi Glass, the Guardians, AGI Glasspack, they all have presence in our country. And if we talk about the small scale sector, then the Firozabad in Uttar Pradesh, that is one of the largest small scale glass sector in our country. And if we talk about the type of fuel being used in the glass manufacturing in India, it is natural gas and the furnace oil. And if we see the energy consumption pattern, then the specific energy consumption for the glass manufacturing in the country, it is quite high. It is more than 5,000 kilocalorie per kg for melted glass. And if we talk about, just to give you an idea of the importance of the sector, it is one of the high energy consuming sector. It is consuming around 1.2 million tons of oil equivalent per year. So that gives you an idea of the sector that we are talking about, the glass sector. And in terms of the future scenario for the glass sector, as you see in our architectural aspects in the building, we are using a lot of glass now, the flat glass. And similarly, with the increase in the automobile sector and the packaging industry, specifically for the pharmaceutical, liquor, and the perfume sector, the glass demand in future is going to increase. So it is expected that 10 to 12% annual growth rate will be there for the glass sector. So apart from the production, the energy consumption pattern, that will also increase. So there is a need for the glass sector in the country to conserve energy. Just to give an idea about the glass manufacturing process in general, so basically it consists of 4 processes. It's a batch mixing, then it is melting and refining, forming, and then the finishing. The main part is the melting and refining, because it is the main portion where the lot of energy is being consumed. And if we talk about the glass, then based on the chemical composition, theoretically it can be said the soda lime glass or the lead crystal glass based on the raw material constituent. But if we go in the market, then the market classifies the glass as the container glass. As we all know, for the bottles, the packaging industry, it is a container glass. The one we use for the windows or automobile, it is the flat glass. These two are the major category of glass in any country, Europe, US, India. Apart from that, there are few minor production of other special glass or domestic glass, like we have kitchenware or cookware, the Laopala series in India, and some fiber glass, where we have glass fibers and some polymer reinforcement, which is used for special purposes. So these are in general the different type of glass in country. If you see the energy consumption pattern in the glass manufacturing process, so whether it is a flat glass or it is a container glass, you see the main energy is being consumed in the melting and refining. They are the main energy consumption is there. So it consumes more than 80% of the energy is being used in the melting. And a lot of the energy that gets wasted. In glass sector also, if you see the energy cost, it is more than 25%. It may be as high as 40%. So the energy cost is one of the pinching factor for the glass manufacturer. So he always looks for the ways by which he can reduce its manufacturing cost. If you see typically the energy flow pattern for the glass sector, then whatever energy we give as input for glass manufacturing, majority of them get wasted. Even for the best practice furnace in Europe, the efficiency is around 40%. It means the 60% of energy that we give for glass manufacturing that get lost. Around 30% of it get lost through the structural losses, and balance 30% it goes through the flue gases. So there is large amount of possibility to tap this waste gas, and the waste heat recovery that gives one of the best option to conserve energy in the glass manufacturing. One of the main reason is that the glass furnace is very high temperature melting furnace, where the melting temperature is as high as 1500 degrees centigrade. So the flue gases that leaves the furnace, that leaves at very high temperature. It's around 450 or 500 degrees centigrade, or maybe as high as 800 degrees centigrade. And if we see the potential for the waste heat recovery, then smaller the size of the furnace, the larger is the heat loss. And if we see typically for the float glass furnace, they are very high capacity furnace, around 500 to 1000 tons per day furnace. Similarly for the container glass, the furnace size is very high. But when we talk about the press or blown furnace, the smaller furnace, the textile fiber furnace, they are small. But nevertheless, whether it's a small size tank furnace or a large size tank furnace, the potential for waste heat recovery is very high. And in the glass sector, the waste heat that we can use is basically for preheating the combustion air that we are going for to the furnace. We can use that waste heat for the batch preheating or the cullet preheating. And also we can use that waste heat through boiler for electricity generation. So there are different options in the glass sector where we can use the waste heat. If we see theoretically, the combustion efficiency of the furnace that I told you, it's around 40% for the glass furnace, it can be increased by 50%. It's a theoretical, but a substantial part of it, this waste heat can be recovered. As I mentioned, the expected growth rate for the projected growth rate for the glass sector in the country is around 10 to 12%. So if we see the potential for electricity generation from the glass sector alone, it is very high. Around 36 megawatt of electricity can be produced simply by using the waste heat recovery in the glass sector in India. Apart from glass, there are two other sectors which are important for our country, the cement and iron and steel. And my colleague will be speaking on, I think, cement sector. So this is about the glass sector and the potential of the glass sector in the country. Now let me talk about one of the work that TERI has done in the glass sector. It is one of the largest cluster in terms of glass manufacturing and also in terms of total energy consumption in clusters in India. It's the Firozabad. And the annual production of glass in this cluster is around 1 million tons, and it's very high energy consuming cluster. And the major product they produce in the Firozabad is bangles. And it is, I think, one of the only cluster in India where the bangles are being produced. And apart from bangle, they also produce some color decorative items, tableware, and the glass shells. But Firozabad is mainly known by the bangles. And the typical location of this cluster, it is around 40 kilometers from Agra. So it falls under the Taj trapezium zone. And traditionally the sector is using the coal as main fuel for glass manufacturing. So the Supreme Court, Honorable Supreme Court in 1996 mandated the industries in Firozabad to switch over from coal to natural gas. So at that time, TERI, with the support of Swiss Agency for Development and Cooperation, SDC, they worked in that cluster and developed energy efficient design. And TERI worked very closely with the industry association as well as the local service provider. My senior colleague Prashantopal highlighted the importance of local service provider, and this is one of the best examples in which TERI had worked extensively with the help of local service providers. Almost for last more than 20 years we are working in that cluster with support of SDC, and we have developed an energy efficient pot furnace and also a waste heat recovery system in the cluster. The waste heat recovery system is basically, it's a modular system, and it's basically working on the principle of the counterflow metallic recuperator. It's independent, 5 modules are there, 5 stainless steel modules are there, and the ambient air is basically heated up to 600 degrees centigrade, and these recuperators are basically placed between the furnace and the chimney at underground level. Basically, underground, why we have kept it underground is because we don't want to interfere with their operating practices. So traditionally they were having the flue gases underground, so we kept our recuperator underground. And the cost for this recuperator is around 1.2 to 1.5 million. It's very high cost for an MSME entrepreneur. But if you see the payback period for this recuperator, it is less than 1 year. And the energy saving is more than 25 to 30%. And we are very proud to say that almost all the units in the cluster in Firozabad, they have adopted this design, the recuperator design, and it is being known as the TERI design. But TERI, apart from working with the local service providers and industry association, TERI also did the competence pooling in this cluster. We worked very closely with the British Glass and Sorensa from Switzerland, and their expertise, along with the help from the local industry association, this design was demonstrated, replicated to all the units in the cluster. Thank you for your kind attention.
Thank you very much.